malloc and released with free. This is also available in C++, but C++ code more often uses the new and delete operators. Let's make a working copy of memory.c here, and we will paste this into our working project. So I'm including the standard lib header, which has malloc and free, and I'm also including the string header because strcpy is being used here, and that's in the string header. stdlib, stdlib.h has malloc and free, and if you're using C++ and want to use malloc and free, you would use the cstdlib without the .h to have those function headers. So we start out by declaring some constants, a size for our buffer, a constant string to use as a source, and then on line 9 is a pointer to a character, and that pointer is named string, and it is initialized to null. So we're going to use this pointer for our allocated memory once it happens. Down here on line 11, we print out a string that says allocating space, and then on line 12, we actually allocate that space, and we use malloc. Malloc takes one argument, which is the size of the space to allocate, and it returns a pointer, which can then be assigned to a pointer variable and used to reference that space. So you'll notice that for the size, I'm taking the size constant, which is str size and is defined there on line 7, and I'm multiplying it by the size of a character. And the size of a character is 1. It's 1 byte. But if I was trying to allocate space for, say, 1024 ints, then I would use size of int. And just because I'm using size of char, I still use this syntax because it's clear. And it's the right way to do it, even though the effect is the same as just putting str size there. That way, if I change the size of a thing, or if I need to come back and modify this code, it's really easy to do. On line 13, I test to see if my pointer is equal to null. And if it is, then I print out an error, cannot allocate memory. And then on line 18, I use str ncopy to copy my string. And then once we've used this thing that we've allocated memory for, we go ahead and free the space using free on line 22. Free takes the pointer that has been allocated. It must be exactly the address of the beginning of the allocation because that data is stored elsewhere in memory in a table of things that have been allocated by malloc. And then free will use that pointer to look it up and then free up that memory. And then it's not necessary, but it's always a good idea to return the pointer to the state of pointing at null. If you leave it pointing at that unallocated memory, then you're opening yourself up to trouble. So let's go ahead and save this and compile it and run it. And there we have allocating space for string. We've copied it with the str ncopy in line 18, and then we free the space. So keep in mind that all of the memory that you allocate with malloc must be freed with free. You can't just expect that it'll just get cleaned up when your program exits because that's not always true and you can end up leaking memory and crashing your system. There's one other function here that is worth noting, and it's called calloc as opposed to malloc. So if we just change this m to a c, and then we need to also change our syntax here. And so that multiplier now becomes a comma. The syntax for calloc takes the number of things that are being allocated followed by the size of the things that are being allocated. And in fact, it simply multiplies these two numbers together just like we were doing. So if you get them backwards, it'll probably still work. And other than that, it returns the same thing. It returns a pointer. The distinction is that after it allocates this memory, it'll go out and write zeros in it. And sometimes that's handy. In practice, when you use malloc, oftentimes if you just look at the memory after you've allocated it and before you do anything with it, you'll notice that it's all zeros anyway, and you'll think to yourself, well, why do I need another function for calloc? And the reason for that is that malloc is not the thing that's clearing it. And if you use a lot of memory and clear it and use it and clear it over and over, you'll find that things will be left behind. And even if your system normally clears out a lot of memory when it allocates it in the very first place, which some systems seem to do, using malloc and free, you're going to find that that memory is not guaranteed to be clear. So calloc, it allocates the memory and it clears it, and that C stands for clear. So if I now save this and compile and run it, you'll see it appears to work exactly the same. The difference is that it's gone and written zeros. It has actively written zeros to that space after it allocated it. So the other thing that you may be wondering is, when would I want to use malloc and free? And if I'm using C++, when would I want to use new and delete? Well, if you're using C and not C++, then the choice is easy. New and delete are not available in C, so you'll use malloc and free. If you're using C++, you need to think about what it is that you're allocating. If you're allocating primitive types that don't need or have constructors and destructors, malloc and free will work fine and may even be more efficient in some circumstances. Otherwise, stick with new and delete because they'll actually call the constructors and the destructors. So here are the function signatures for the functions we've used in this lesson. Malloc returns a void pointer, and a void pointer is a special kind of a pointer that can easily convert to any other type of a pointer. And it takes as its one argument the size of the space in bytes that you will want to be allocating. Free is a void function, that is, it doesn't return any value, and it simply frees up the memory that is pointed to by the pointer that you pass it. So you pass it one pointer, and it frees up that memory. calloc is exactly like malloc, except it takes two arguments. One is the number of things, and the second argument is the size of the things that you want to allocate space for. And it simply multiplies them together to get the amount of space to allocate. Malloc provides basic memory allocation services for C and C++. C++ also provides the new and delete operators, which call object constructors and destructors. Be careful not to mix malloc and free with the new and delete, as they are not compatible. Now let's delete our working file